Hello everybody. This video is for anybody who teaches science or mathematics or parents of students who are coming home from school with books like this where all the science is in different chapters as if it was completely unrelated. Now there's something wrong with science. Science, as you progress and go to university, begins to fall apart. That science book has the solar system. But when you get to university, deal with books like this, there's no solar system. It's not allowed in physics books. Now that's very, very shocking, but people don't say it. So let's state it today. Science falls apart into all the different disciplines that we have in a university, and nothing seems to hold them together. But we live in a single reality that we experience when we go outside. It all works together. So why can't we say how it works together? Well, there's a real problem, and that was best put by Richard Feynman when he said, if we look down at the base, the little bits that make all of reality, can we find something that tells us how reality really works? If we look in the equations of quantum mechanics, we cannot see frogs, elements changing into living things, musical composers, everything we love about being human, or morality. And so we can all hold strong opinions either way. So that's the big problem in science. If I look down at the building blocks, I can't see how they make anything complex. The solar system has some parts which are chaotic, and that's not allowed in physics. Other parts which are very regular, the orbits of the planets. So I've got a mixture of both chaotic and completely predictable. So I can't have the solar system in my physics book. The orbital resonance, which brings it all to work as a big clockwork mechanism, that's not physics, it's perturbation theory, and harmonics, and even mathematics, pure mathematics. And if I look down at the atomic level, I've got the elements. If I look inside a book containing the elements, I don't find DNA. Look at the elements in here. This complexity cannot ever be described by the physics that describes the elements. So there's something happening here, the complex reality that we live in. The simple physics that we call relativity at the big scale, quantum mechanics at the small scale, and the reality that we live in is over here. There's a huge step here. Something happens here. Now, this video, I can tell you what happens here. Why we find that the reality over here just all falls into different fields that don't seem to fit together. The weather, completely chaotic system. It's not like the solar system. So I've got chaotic systems. The solar system, self-organizing system with chaotic parts. Life, what happens inside a cell. The elements, and only the elements in very, very complex dynamic systems. That needs an explanation. If I look at genetics, I only see the elements. If I look the hideous complexity in my chemistry book, an organic chemistry book, I only see elements. And if I look in my biology book, human physiology, I only see the elements. But the elements start to think and talk and become aware of themselves. So that's why we have such difficulty. So let's answer the question of what happens here when I go from my two parts of physics into the complex reality that we experience. We do understand complexity, but that comes in books like this. This is the first really good book written about chaos and non-linear, unpredictable mechanics. It was written by Robert C. Hilborn. Now this is pure mathematics. There is no physics in this book. But what it tells you is that all complex systems use the same mathematics. And there are logistic maps which describe the behavior of the complex system. The first three systems he describes are turbulence in a fluid, population, foxes and rabbits, and then an electrical circuit. And he also states that complex behavior has nothing to do with the physical components, the foxes and rabbits, an electrical circuit, and turbulence in a fluid all show the same mathematical patterns. Now they have unpredictable outcomes, and the only things that we can predict are where their systems will bifurcate and the size scaling of the bifurcations. So I'm not left with very much to go on. It's unpredictable, but reality is a mixture of unpredictability and the nice predictable physics that we've got over here. So let's pin down the problem that we've got here. This is very, very important. Now you won't understand this by watching this video once. You have to watch it again and again and again. Physics, reality, brings itself into being. And each time I get a new element, helium behaves very different from hydrogen. I get new behavior, a new component in the universe that was not there before. Lithium, it's a metal, behaves very, very different from helium. But I get new physics in lithium that I can measure and quantify. Water, when I start to put the elements together, I get new physics which I can quantify and measure. But when I go over into the complex world and look at the elements in the DNA, it's the same elements. There is no new physics, nothing I can measure and quantify. And that's the big problem. This is called the hidden reality. And here's a book by Brian Greene, The Hidden Reality. That's why it's hidden from us. Because if I look at the parts of the solar system, it's the same physical parts, but behaving in a completely new way. And there's no new physics. So that's why it's hidden. It's the same parts, no physics, nothing I can measure. So we're staring at the elements in DNA, saying it's just the elements, but now look how complex they are. Over here, I've just got quantum mechanics. But look at this complexity that I get here. And the physical components inside a cell, this is the Krebs cycle, doing something very, very different from just being elements and sticking together and making a block of aluminium or something. Very, very different behavior, but nothing I can quantify that's showing me how this behavior happens. It's pure mathematics. So that's the problem. What happens here? The difference between physics and complexity. Now you can check that. Go away and test what I just said for logic. Now I'm going to answer that. And you can check the answer. There's one single answer that explains how the whole of reality fits together. That answer is, we must describe reality in dualities, not as single mechanisms. And that shows up specifically with the way that we describe the second law of thermodynamics in physics. The second law of thermodynamics says that the energy in the universe is always wearing out, it's always becoming less useful. That is true. But if I look at the matter, it's not always wearing out. It starts here very simply as some quarks, electrons, neutrinos, which change into protons and neutrons, which change into stars and elements, which change into more elements, which change into elements sticking together and making things like water, which change into solar systems, which change into molecules, which change into life and viruses. The matter, as the energy dissipates and becomes more disordered, becomes more ordered. If I describe it as a duality, what I know about one, I can see reflected in the other. It's an inverse. Now, let's describe reality using dualities, and you will see that my contradictions disappear and it doesn't all fall apart. Dualities, everything must be seen as dualities. Now, there are two kinds of dualities, and you can see here in mathematics. I've got numbers which are positive and negative. They're inverses of each other. One is an exact reflection of the other. But if I've got a 0 and a 1, I've got opposites. So I've got two different kinds of dualities, inverses and opposites. Inverses, what happens in one is reflected in what happens in the other. An opposite, this is not this. But inverses and opposites, when they're together, interact with each other, and that's what we call forces. So let's describe the universe as interactions between inverses and opposites, and I must have a dual answer. That dual answer shows up here. This is mathematics, not physics of the proton and the neutron. The physics of the proton and the neutron is the energy. Now, the proton and the electron both have an amount of energy which is not plus 1 or minus 1. It's 1.6 times 10 to the minus 19 of a coulomb. Now, they both have that amount of energy, but I can't describe that unless I use the mathematics of positive and negative. So I need two answers to describe what's happening in physics, reality. I can't just use the energy. Now, some people say, oh, well, mathematics, that's just what we use to describe reality. But that's not true, otherwise we couldn't be here. So if I look at a snowflake, who's doing this mathematics? It's doing itself. We see mathematics all over nature. This fossil, 250 million years old, and there's a fractal mathematics. They're exactly the same. What is doing the mathematics? Well, if I describe reality as a combination of pure mathematics and physics, I get a logical description of reality. I need a pure mathematics of harmonics, resonance, perturbation theory to describe what's happening in the solar system. I need pure mathematics, group mathematics, to describe what's happening at the molecules. And systems, complex dynamic systems, we find chaotic, like the weather, or self-organizing, like the solar system, or life, genetics, viruses, and energy. There are two kinds of systems. The flow of information, that's DNA. The flow of energy, what happens inside the cell. And this makes this, and this makes this. It's a dual answer. So let's go back to the beginning and see that dual answer working here with stars and elements. That's the atomic level, that's the gravitational level, but it's this star, the gravity, which is a relationship between the matter and the space. It's the gravity which is pulling together positive particles here, and it's the energy released at the atomic level which is holding that star up. It holds it in existence. So that is a dual answer. The old book would say that gravity makes the star. It doesn't. By itself it can't make the star, because if you just have gravity, the star is big enough to disappear into a black hole. That doesn't happen because the energy being released from the elements holds the star up. So I've got a pull and a push. They're acting against each other. It's a feedback loop. I've got interdependence here between this and this, making this and this at the same time. Now let's go back even further and see that that applies to everything. If I look at the proton and the neutron, these two manifestations of quarks, but they behave completely differently, but I need electrons and neutrinos to change this into this. So I need what's happening here to say what's happening here. And when these change from this into this, these pop out. But if I look inside a neutron, I don't find an electron or a neutrino. It changes its behavior into something new. So I've got up and down, inside here, the two different kinds of quarks, the duality, holding this in existence. And the nucleus of every atom holds the neutrons in existence. If you take them out, they decay. So that's, the neutron is holding the nucleus in existence, the nucleus is holding the neutron in existence. So let's look at my duality now with the parts of matter and space. This is an opposite. I've got inverses, positive and negative, but I've got opposites, what's happening here, what's happening here. Space. Now, general relativity tells us what happens in space affects the matter, turns it into spheres, but the dual answer says the matter also changes the space into spheres. It's trying to shrink it down into a point. It's the density. Forget the rubber sheet nonsense. It's the whole of space but trying to go down into a point and gets held up by the energy. Planet's very different. That gets held up by the electromagnetic repulsion of the particles. So again, I've got a different duality. I've got two different kinds of entities at the gravitational level. But my space. So that works, we call that general relativity. But if I go down to the small level, if I take any little piece of matter, like that, that is not held together by physical bonds. It's held together by bonds which have no physical properties. It's the space in between the atoms which is connecting the matter. Now that's a very, very different way of saying it. The space in between the atoms. And if I look at a magnet, or the Earth, outside is a magnetic field made of space. Now that is a distortion of space just the same as the gravitational distortion of space. So let's solve that problem. If I consider that space is made of mathematics, here I've got real numbers, units in the real world. They're only real because they act against other units as real units. If I take something like a neutrino, which we call as matter, it will go through a light year of lead and not even notice that it's there. So it's how things relate to each other which tell you what they are. My imaginary numbers of space. Now I put mathematics, physics together. The imaginary numbers of the virtual particles which make the magnetic fields outside the magnet and hold the magnet together. I cannot describe reality as a single mechanism. It's the empty space in between the particles which are connecting the particles. I have to say that that is a logical reality. But it brings magnetic fields and electrical fields in the space outside the Earth, puts them together with the gravitational fields. So now let's show, I've got a diagram that now fits in dualities. I've got space, the imaginary units of mathematics, the real units of matter which will interact with light, that's quantum electrodynamics, that's general relativity. But now I've also got this relativity here, the magnetic fields and the matter producing the magnetic fields. What's happening outside the matter is caused by the matter, and what's happening outside the matter is causing the matter to change. So I get a diagram like this. My real numbers, light and matter, positive, less energy, negative, strong fields, positive, weak fields, negative, a relationship between them. And I get interactions between inverses and opposites. And it's those interactions which bring change. So time must fit into this diagram now correctly. And now, because my second law of thermodynamics has become a duality which allows the matter to become ever more complex, and I can go from the simple physics into the complex behavior here just using pure mathematics, I get a diagram like this. It also solves the problem of how I've got two different parts of physics, the physics of space, the physics of matter, relationship between them makes gravity, that gives me stars, but the relationship between them also holds the elements together. So I get classical mechanics, and my physics is down here, nice and simple. But now, add it to mathematics, and I get complexities, I put molecules here, orbital resonance, the moons of Jupiter here, making a clock. I get mathematics and quantum particles, making the biggest mathematical patterns. And gravitational patterns, I get the same patterns, I'm using the same mathematics. But now I've got this mathematics, which has, again, a duality. You'll see their inverses, chaotic systems, or self-organizing systems. I get a reality based on dualities. These two different parts of physics now become inverses. What happens at this scale, and what happens at this scale, are inverses. What you know about the quantity, you don't know about the position and the momentum. But here you know the position and the momentum, but the quantities are all different. They're inverses, and I don't have to try and squash them together in a single set of physical laws. I've got a set of laws based on a duality between mathematics and physics. It's a duality, and I can't describe reality unless I've got all this mathematics. It's pure mathematics, but it doesn't matter that it's not physics. It's the same physical components going from here to here, but now it doesn't matter. I can just say that that's the way the universe works. It flips over from simple behavior into complex behavior, and the same components start to behave very, very differently. Complex systems have interdependence that hold the system in existence. So that's my new definition of what life is. A star, we say the star has a life, lives and dies. It's held in existence by this interdependence between what's happening at this level and what's happening at this level. It's the interdependence here which I can't see. It's not in the physical components. And it's because you can't see it that it's the hidden reality. That's why it's hidden from us. The same parts just do something different. Now, that's logical. Everything in the universe starts very simple, becomes ever more complex. It's the matter becoming complex as the energy runs down. I get a logical explanation of everything in the universe. Now, I also need time and put it into the same pattern. Into action, if I just put these parts together, the imaginary parts and the real parts, I get gravitational objects, I get matter, I get classical objects, but remember, classical objects are not held together by physical bonds. It's what's happening in the empty space between them. I just put these together, I get change, I get stars and elements, I get time building itself. And I'm not contradicting anything in the second law of thermodynamics. As the energy goes up, the matter becomes more and more complex. And I've got now a mechanism for how it becomes complex here. It's all in books like this. You need to check it out. He states in the book that complex behavior is nothing to do with the physical component. And he says that physics is something that's very specific that we're just doing in laboratories, and that physicists have to cast off the blinders which have been holding us back behind this barrier. I can now teach science and mathematics as something which is all two manifestations of the same thing. So if you're teaching imaginary numbers just as some abstract thought, you need to think again. Think of a magnetic field or space itself. That gives the brain something to hang on to. I get time. Now, evolution of stars and elements changing into solar systems and molecules and life, all based upon e to the x. Now, e is the value of its own rate of change. So time becomes change. When it's composite, building things, we can say it's positive. When it's decomposite, when a star explodes or something dies, my interdependence is lost. It starts to break itself down, puts something into water, it dissolves out into smaller and smaller components. That's also described by the exponential function, how a hot piece of coal distributes its heat, both the exponential function. We need these to be the same mathematics to fit with something called Noether's principle, which shows that the two parts of time must be homogeneous. So now we've done that. So now we've got an answer, a clear, clean answer that you can go and test. Now I work here in Asia. I'm just an ordinary person. I work with professors at the universities here, and I went to see one particular professor, Dr. Gideon Lovey, Professor Gideon Lovey. And he spent 3 years sorting all this out, putting it all, getting it all correct. And he said, well, you need some more mathematics here. Well, we have got some more mathematics here that shows that all these 6 parts are the same mathematical value. And that is a relationship between E and the zeta function. And if we go back here, the relationship between what happens in the imaginary parts of space, the connectivity between the particles, is something called a Mobius function. So you can fit together all the parts of mathematics and physics. Now that's really important, that we've got something now which is a logical description of reality that doesn't need other universes. Like the many worlds theory, I need other universes to describe what's happening here. My wave-particle duality problem, it could be both at the same time. Matter behaves as a wave relative to space. Space now we know behaves as a wave relative to large amounts of matter we call black holes. It's the inverse. This is the individual behavior as a wave. That's the collective. Again, I get my 2 answers. Individual atom of lithium behaves very different from the collective. An atom doesn't have properties of hard and soft, but the collective does. So now I can see I've just got these inverse. A particle behaves relative to a particle as matter, but as energy to space. So energy, units of energy, change into what we call matter by acting against each other as something different. We say particles, but it's still energy. So now I can see how the same parts keep changing into different things which have different physics, and then change into parts which don't have any new physics, but they just have different behavior. But now that's logical and it makes sense. Now once you start teaching like this, students learn 10 times faster. 10 times faster. The results that we have, I was allowed to take this into school after it had been peer reviewed in universities for 3 or 4 years. Allowed to take it and give it to teachers. Say, start teaching like this. The results that you get is that students have a clear, simple mechanism for the whole universe working on dualities, which are either inverse or opposites. So when they look at odd and even numbers, they see that this is symmetries and asymmetries, and I get that in the forces, the strong and weak nuclear force, but then I get symmetrical forces, electromagnetic force, and then I get a very, very big opposite between what happens with space and matter. But then, as Einstein showed us, gravity is really just an imaginary force. It's just a relationship between space and matter. And if I look at what balances gravity, that's a relationship between something trying to go along in a straight line, Euclidean geometry, and trying to fall around in a circle, non-Euclidean geometry. And it's a battle between the two of them which opposes the pull of gravity and puts something into a stable orbit. So you can see how easily I can now describe everything, and it all makes sense. So students get this beautiful feeling that we do live in a logical place. And we've put these diagrams into nice charts like this, which go on the classroom wall in every classroom, and this one here, and I see my inverses and opposites in the Mandelbrot set. I've got 2 inverses and a head and a tail, and then I get what's happening inside and what's happening outside, just the same. And all this is based upon prime numbers. 1, which is the first one, 2, which is symmetrical and asymmetrical, and Nikola Tesla already showed that numbers, primes and composites, are a self-organizing system. You can go and look that up on the internet. So here we have a reality which is logical. Now you have to go back and look at every sentence that I've said. Is it logical? Is it true? What we know, or isn't it? And if you find that yes, it's logical, the disciplines of science say you cannot go back to teach something illogical that all falls apart. We are not allowed in science to carry on regardless. When we get some new information, some better information over here, I get a sociological compulsion to go with tradition. That's how societies form. But that's why we use science to get round our compulsions that my family is best, my country is best, and deal with a logic which is outside human beings to look back at us and say what we are. Layers and layers and layers of complexity, each layer bringing in some new rules. So I've still got the atomic rules down here in my body, but then I've got the rules of elements, then I've got the rules of complexity of complex systems, of what's happening in the DNA, balancing what's happening in the cell, what's happening in the cell causing what's happening in the DNA. Then I get my social behavior, so I've got a few simple sets of rules that humans respond to. I simply copy the behavior around me. When I'm a baby, I just copy any behavior. That brings in a social group that I respond to. I've got my individual behavior, I want to stay alive, I want to reproduce. I've got this dual behavior. I exist as a pair, a sexual pair. Nobody, there is no human being which is asexual, a single sexuality. There isn't one. There's always both, just more one than the other, or something in between. So that clears up that problem. Now, if you want to find out a bit more about this, we'll put some email addresses on after the program. You can have a look at them. Get in touch with us. Start using this. If you carry on with that, students get to a point they become very confused. There's chemistry, there's the mathematics of genetics, there's physics. They just get lost. They know that something's wrong. They get a very uncomfortable feeling that nobody can explain this correctly. But people like Brian Cox, a very, very good scientist, he knows that there's this problem. So when he's talking about reality, he uses an expression. He says the laws of nature. Doesn't say the laws of physics. It's not allowed, because the laws of physics are simple and over here. And the laws of physics and the laws of complex behavior, chaotic behavior, fit together here. Now, we've been waiting maybe 300 years for this answer, with Newtonian mechanics giving us the idea that one day everything would turn out to be all nice, predictable physics. But that was just a hope that we would have as people. Reality, we don't want to be predictable. And that's what makes it interesting. So share this with as many people as you can. Talk about it. It's you, the ordinary people, who are going to bring this into reality. It's just logic. There's no new science. There's no new experiment to do to verify. It's just logic. Is it logical or isn't it? So here we have a change brought about by ordinary people using the internet. Just us. We can do this. We must do this. Because I am very, very fed up teaching nonsense that doesn't fit together. Now we show industry how all this works. And they love it. They're now starting to use mathematics to describe viruses. It's pure mathematics, it's brute mathematics. They can see what they're doing at last. So get in touch. Check this out. Study it. Do your homework. Let's make a change. Bye-bye now.